Okay, let's take a look at the second question, which is, what would be the pH after the addition of 10 mL of sodium hydroxide? Now, in my previous video, I explained to you that when it comes to titration, it involves the number of mole, and therefore you have to calculate the number of mole for the hydrochloric acid and also the number of mole for the sodium hydroxide. So let's begin. So let's start by calculating the number of mole for hydrochloric acid, which we have 25 mils. I'm going to use MV over thousands, 0.10. Get this, and we're going to get 2.5 exponent negative 3 mole. Okay, so this is the number of mole for hydrochloric acid. Next, let's calculate the number of mole for sodium hydroxide. So we have here 10, and okay, we have 0.1, and we have 1000 as usual. So I have 1.0 exponent negative 3 mole. Okay, so we have this number of moles. Now, the next step is we have to see how the reaction goes between those moles. So I encourage you all to prepare a timetable, or you can just write like this. Okay, so we are going to use all the mole. So our initial here will be our initial for mole. Now initially, okay, we have this 1 exponent negative 3. So we're going to put it here. Our hydrochloric acid, we have 2.5. Now, initially we don't, before the reaction, okay, before the reactions, so we don't have the salt yet, we don't have the water yet. Now, what is the changes? Okay, in this case, since this reaction is 100% non-reversible and it is a one-way reaction, so the reaction will be just a forward reaction. And for the changes, we have to consider the smallest mole, okay? Which is why, because the smallest mole will become the limiting reactant. So as you can see here, between sodium hydroxide and hydrochloric acid, the smallest mole involved is, the smallest mole involved is this, because it only has 1 exponent negative 3, and if you compare to the hydrochloric acid, it has 2.5. So the one that will finish first is the sodium hydroxide. So this will be the changes. So here as well. Okay. So we don't have equilibrium. Remember, this is a forward reaction. So it will be final instead of E, equilibrium. So this one will be 0. This one you minus and you're going to get 1.5 exponent negative 3. This one 1. And this one 1 as well. Okay. Now as you can see, okay, we only look at these two. Now, after the reaction, we can see that sodium hydroxide left nothing. Okay, it's 0. But still, we have the excess, not excess, it's like, excess baki for the hydrochloric acid, which is 1.5 exponent negative 3. Which means, if I can draw it, okay, if I can draw in your what we call this, in the conical flask, okay, initially it has 2.5 exponent negative 3 moles of acid, hydrogen ion, but after the additions of 10 mils of the sodium hydroxide, it left 1.5 exponent negative 3. So the number of hydrogen ion is decreasing, and by right, the pH should increase. Am I right? Okay. The number of mole of hydrogen ion decrease, and therefore the pH should increase. Okay, so how can we prove this statement? By calculating. Okay, so we have 1.5 exponent negative 3 left. This is mole. So next one, okay, so number of mole left is 1.5 exponent negative 3 mole. To find the pH, we have to calculate the concentration, because for pH we need the concentration. Okay, so calculate the concentration of H plus. The concentration of hydrochloric acid. Okay, I'm going to use mole over volume. So what will be the volume? Okay, here it is. The volume is no longer 10 or 25, but it should be 25 plus 10. Okay, I'm talking about the volume in the conical flask now. Initially it is 25 ml, but with the addition of another 10 ml, so now the volume is 35 ml. Okay, so to calculate the new concentration of the hydrochloric acid, we need to add like this. Okay, so this one I will divide with 1000 because I want to get it in liter. So you can pause, you can calculate first. In the end, you're going to get 0.043 molar. Okay. And we know that hydrochloric acid, it is 100% ionized. 0.043 molar. No, I'm wrong, sorry. We're going to get H plus Cl minus. So if it's initially 0.043, final, it will be 0. This one will be 0.043 and 0.043. But we are only looking at this one, okay? Because we want to calculate the pH. Okay, write the formula, substitute the value. Okay, you can pause, you can take your time to calculate. So this one will be 1.36. So if you compare before the additions of sodium hydroxide, the pH is 1, but after the addition of sodium hydroxide, the pH increased to 1.36. Okay, so there you go, the calculations of pH after the addition of sodium hydroxide. So the next question will be in the next video.